Okay, now let's look at components of the sine and cosine functions just to review. So here's the graph of the sine function. This is the parent sine function, the red graph right here. And so first thing is that the amplitude, that means basically the stretch factor for the graph. The amplitude is basically the distance from the maximum or the minimum to the basically the midline. Okay, so in this case our midline is the x-axis, so the distance between that and the maximum is 1, so as the distance from the minimum to the midline is 1, so we call that an amplitude. Now in terms of the actual like a formula for it, when you take the maximum value, so this is your maximum value right here and this is your minimum value, and when you subtract minimum value from the maximum divided by 2, you're going to end up getting the amplitude, and it's always positive. Always positive, is never negative. Okay, the period is 2 pi, that's the full cycle going around the circle at 360 degrees, or 2 pi. The maximum minimum 1 and -1, we saw that here. So this is our maximum, this is our minimum right here. Okay, and the other parts are x-intercepts and y-intercepts. So x-intercepts for the parent function of the sine, we have 0, pi, and 2 pi, and then of course with the for the y-intercept we have only 0. That's basically it. It is periodic and it goes forever. It's the same idea. So this was the graph of the, remember, this is for y equal to sine of x. Okay, and it's the same thing for the cosine. Okay, so again, notice that this distance here, same as this distance, same as this is all, they are all called the amplitude, AMP, and it's sure enough, it is 1. And then we're going to go ahead and write up the rest same as the sine. Okay, so we have the amplitude at 1, they are all 1, and then the period is 2 pi, so we start here and then end at 2 pi, so that's our 2 pi period right there. Then we have a maximum and minimum, our maximum here and there, which is the same at 1, that's our maximum value, and then our minimum value is down here, which is our, that's the minimum value. Let's change that to yellow. Here we go. And then x-intercepts. The x-intercepts are a little bit interesting because different than the sine function is being shifted. So it's pi over 2 and 3 pi over 2 are our x-intercepts, and our y-intercept is now 1. That's our y-intercept. So that is very important to, so y-intercept is 1 now, so it's not 0. But that's basically it. Same idea again. Okay, this is the graph of y equal to cos of x. All right, now let's explore the standard equation of the sine and cosine and the components of that. If you remember from the polynomial function unit, where we had components with the standard form of a polynomial function, it applies here exactly the same. Nothing is different, nothing has changed. So we have A, we have B, we have C, and we have D, and as usual the leading coefficient for the function, that will be basically your vertical expansion and compression. But in this case, in a periodic function, we call that the amplitude, the absolute value of that. Okay, so that's the same thing. So that number in front shows up, that gives you the amplitude. That deal with B as well, that's a horizontal expansion and compression. And in this case, this represents, the B is the value that you can use to get the period of the function. Okay, that's your basically horizontal expansion compression as well. So let's go to Desmos. Here is an example of the y equal to sine x. Now what happened when we had 2 in front of a function from a polynomial unit? Well, that was a vertical expansion. That means this value right there, which is at pi over 2 and 1, should be pi over 2 and double. stretched vertically by a factor of 2. So the entire graph will be shift up, or stretches up, and then this value, the minimum value, stretches down to -2. Let's look at it. Here it is, okay, the green graph. So it stretches up by a factor of 2 and down by a factor of 2. Now, what happens, you think, when we have a half in there? That was the vertical compression by a factor of half. And sure enough, it is right here. It's been, the amplitude has been halved, really, right? So in here as well. So that's what it is. And the same idea, these two exactly, I use them just a sine function, but applies to the cosine function. For the b value, I'm using the cosine function to show you how that's implied. So let's go to cosine function. Here is the cosine function, very simple. Now the 2, what would that be if the 2 is the leading coefficient for the x, the argument of the function? Well, that will give you a horizontal compression by a factor of half. Let's look. So what that means is that this pi over 2 is going to shrink halfway between 0 and pi over 2, and the entire period is going to be shifted by half. Sorry, it's just compressed by half. So that means the period of this function, instead of being 2 pi, it will be only pi. Let's look at it. Here it is. Okay, simple as that. Look at that. This graph went from the full cycle ends at pi instead of being 2 pi. So basically any part of this, you can see that is a horizontal compression has happened by a factor of half. Now what happens if you do 1/2? Well, that would be the horizontal expansion. Now the period is not 2 pi anymore, it becomes 4 pi, and I have to adjust the graph, but here it is. So let's adjust the graph. Now you can see that here it is, the 4 pi. We go from 0 here to all the way to 4 pi, and the blue graph is being stretched by a factor of 2, is doubled. That means the period has been doubled. So how would you get the period of this thing, which is 4 pi? Well, 4 pi, so 1/2 or the 2. If you get 2 pi divided by this coefficient b, you'll get the period. 2 pi divided by a half will give you 4 pi. That's the period. Okay, so simple as that. This is how you will deal with that. And guess what happens when you're shifting it up, down, with the or left and right? It's the same components of the equation, the c component and the d component. All right, so bring it all together. So here are the functions that we have. Y equal to sine theta, the red graph. What happens? You put a 2 in front, the amplitude doubles, the stretch factor, vertical stretch. That's the graph of that. If you have y equal to sine theta, you start with, and if you go 1/2 sine theta, there would be a vertical compression. Notice that the vertical value here, it turns out to be a half. And then when we deal with the horizontal expansion compression, that's the coefficient of the argument. So if we go from cos of theta to cos of 2 theta, notice that the period of the function, it's half. So that is, the period is actually, if you want to do the calculate the period, it will be 2 pi divided by 2, which would be pi. So in this case, if you look at the red graph, that is the graph of y equal to cos of 2 theta. That period of that function is half of the period of the original function. And then if you go to the expansion, this half, that tells you that the period is 2 pi divided by a half, which is 4 pi, and sure enough, the blue graph has been stretched horizontally. Okay, great.